right, good morning, everybody. How's all y'all doing? Everybody doing all right? Cool. Sorry for the brief delay there, but I'll get right into it. So we have Oren Novotny here with Blue Metal Architects, and he's going to walk y'all through cross-platform unit testing with xUnit. So, Oren?
Thank you. So how's everyone going today? It's going good? You like Grant's talk about Mythbusters and testing? And after all, that's what Mythbusters really is, right? They're testing things, testing myths. So we're here to talk about a little bit of a different kind of testing, namely the kind that you do in software. But it's still many of the same principles apply. We want to make sure that we get our applications right so that they don't crash in public. So hopefully you are already using unit testing of some sort. If not, this will help show you how to get started. A little bit about myself. I'm a Microsoft and Xamarin MVP. I'm privileged to have that honor. I've been using .NET for nearly 15 years, really since there was a .NET, so ever since the beginning. I've been using Xamarin since 2012. So when they were an itty-bitty little company, it was really been awesome to see the growth of that graph that Nat showed yesterday. So it's tremendous seeing all the changes here. And then more recently, I've been responsible for the cross-platform support within xUnit. So xUnit is a unit testing framework that we're hopefully all here to learn about today. And I'm also the maintainer of the device support for xUnit. And mainly, that's the part that lets xUnit work on iOS and Android and Windows and HoloLens and really any device you can think of. Please follow me on Twitter and on GitHub. My information will be up at the end as well. So today, we're going to look at a little bit about why xUnit. What is it? Why do you care? Why is it, or how is it different than NUnit? We're going to look at some of the examples of its extensibility, and then we'll take a quick dive into how you get started using the device runner. With a look at, see how it works on Android, and see how it works on iOS, and then go into some patterns on how you can get tests to work on either or both or all platforms. So what is this thing anyway? xUnit is a unit testing framework that is designed to be closely in line with the .NET framework. It takes full advantage of what .NET has to offer by design, with extensibility and generics and all the good stuff we've all known to love within .NET. It has its roots from NUnit. So one of the main authors, the authors are Brad Wilson and James Newkirk. James Newkirk was one of the main primary authors of NUnit. So they have a pedigree within the unit testing space. There were a number of changes, though, that they wanted to do and rethink how they created a unit test framework and a runner. So version 1 was written for .NET 2 and released in September 2007 after a year's development effort. And again, that gets back to the why xUnit. NUnit has certain things, and it was designed for .NET 1.0. It was certainly a great unit testing framework, and it still is a great testing framework. But it wasn't fully taking advantage of many of the .NET paradigms. So the intent here with xUnit was to align closely with .NET and focus on programmer testing. So it's really about TDD and BDD. It is also extensible to support other kinds of testing, like automated acceptance testing and UI testing, but it's not the primary focus of xUnit. So then version 2 was a rewrite after version 1 was successful and popular. And James and Brad took to heart the lessons learned, feature requests that came in, how people use xUnit. And one of the core things they took to heart was this idea of extensibility, that the core test engine shouldn't have to predefine everything. And then that means that puts a huge burden on things like the test runners and test executors that might have to understand and interpret these test engine changes. So extensibility is really the key defining feature of xUnit. And the other part of that being that in between xUnit 1 and xUnit 2, the rise of multiple platforms. So xUnit 1 was developed for the .NET Desktop framework, because that's really all there was at the time, compact framework aside. But since between 2007 and really the release of 2.0 in 2015, we started to see Windows Store applications. We started to see Xamarin really get a solid footing. We started to see support for other frameworks as well. So xUnit was designed for portability. It is, the core logic is actually in a portable class library with certain other support for the desktop where needed. But the core feature here is that it works natively on every platform that .NET runs on today. It was released, as I mentioned, in March 2015, and has the following really main extensibility points. And these really let you get in and change and update any part of your test process. Really, so you can assert, that's an easy one, that's low-hanging fruit. You can use the binary as is or its source, you can change it, party on. You can also use any number of third-party assertion libraries. Fluent assertions is a really popular one for those that like the fluent style of testing. xUnit really doesn't have an opinion in this area. It just provides one out of the box and use what you want. It has before and after attributes for test extensibility. Really, if you want to have code that runs before or after each test, there's an easy place to hook that up. That code can live wherever you want, and we'll come back to that. It's really focused on the method, though, and not the whole test class itself. So if you want to just, say, tweak the behavior or functionality of how does this test method execute, you can do that. Then we also have class fixture extensibility. And that's to say that we can have code that runs before or after all tests in a particular test class. And again, that's a different factoring, and there's different instances of where you may want to do that. There's also extensibility around theory data. So you can have data that lives within attributes, certainly, or methods to say, or like an enumerable method to say, hey, let me return things to have data-driven tests. But suppose you want to have tests that are driven out of an Excel file or out of a table or, I don't know, maybe a REST web service if you're so inclined. It's really not that hard to hook that up, and you just extend the right places, and you can have your data coming from anywhere you see fit. You might question your sanity if you're getting unit test data from a web service, but that's sort of a different question altogether. Then there's also things like traits and test ordering and which test frameworks and test runners you can do. So there's really designed to make it really easy to implement a runner. And as a result of this flexibility, there's been a very huge adoption of xUnit, especially 2.0, within the open source community. And within Microsoft itself. For example, all of the .NET Core and .NET Core projects use xUnit as the primary and really only test framework. It doesn't hurt that it's also one of the only ones that works on DNX and Core CLR as well at this point. So how does xUnit differ from NUnit? So let's say quick show of hands. How many people have used or are familiar with NUnit? Okay. How about xUnit? Okay, somewhat fewer. So hopefully we'll kind of shed some light here on how xUnit's terminology matches and maps to NUnit and some of its differences. Because even if you want to say this extensibility is really cool, you got to start somewhere, and you got to know how to map the two. I will say that a complete table of what NUnit does to what xUnit does is in the xUnit documentation online. So you don't have to memorize all of this. It's all there, and the slide deck will be available as well. One of the key differences, though, at least in terms of definitions, xUnit has these tests, right? It's just everything's a test. Well, xUnit kind of tries to have a slight opinion on this, where it has the idea that a fact is an invariant condition. This is always true, or is always whatever you assert it to be. They don't change over data. Whereas you have theories, which are tests, which are only true for a particular set of data. And that's where you have, effectively, your data-driven tests and the like. You can, it is what it is. These attributes are created out of the same extensibility points that you can extend later. So you don't like it, you want to have your own fact, your own discovery mechanism, knock your socks off. So you can absolutely do that. One of the key things you can do with xUnit is have complete control over the discovery process. You want to have a discovery mechanism that dynamically generates unit tests on the fly that the runner can see and execute. You can totally do that. Implement iTest Framework Discoverer. And you can decorate things with certain attributes, and you can drive it however you want. So another key difference between NUnit is that xUnit creates a new instance of your test class for every test method that executes. And this is really for safety. So xUnit doesn't want to make any guarantees or promises over which order your test methods are going to run in, because that tends to lead to bad, dangerous side effects that you don't intend to. If you have shared state in your test class, like what happens if I run test 1 instead of test 2 or reverse? Maybe it'll be true sometimes, but not always. xUnit runs its tests in random order intentionally, so you don't have in unknown dependencies in your test cases. So that helps you improve the test isolation. It also then does away with the test setup and teardown mechanisms. And the idea here gets back to the core xUnit principle of aligning with the .NET framework. It's our opinion that the test setup and teardown detracts from test readability, because now I have to go look at the test class and go find that test method that could be named whatever you want, and go find that attribute and see, okay, well, this is logic that's going to happen at the beginning, and this is then I have to see if I can find a teardown attribute that's going to happen at the end. Well, that's not really idiomatic C#. We have these things called constructors. Please use them. If you really need to dispose of resources at the end of the test, we have dispose. Implement iDisposable, and xUnit will call your dispose method each time as appropriate. So that's sort of the natural place where you would expect to have initialization logic and cleanup logic if you have to have it outside of the scope of your test method itself. I mean, really, the preferred approach would be do whatever setup you need at the beginning of your test. That way, someone looks at your test and can see exactly what's going on without having to jump around what might be a large test file. So then we have, and that plays into the next goal of reducing the number of custom attributes. And really, it's around, sometimes the extensive use of attributes can help you make you feel like you're moved along, diverged from the underlying platform. So instead of relying on, say, test fixture, any public class will do. Just have a class in it, have tests in it, have facts and theories, or whatever other types of tests you want to have in there. It'll discover them. You don't need to have test fixture setup and tear down. If you really need that, there's an extensibility point for called IUseFixture, where you might need to do things like pool connection strings for database type of tests. But again, those are more hopefully the exception and not the rule. Another big one that is gone by design is expected exception. It's just bad. Don't use it. If you take one thing away from here today, even if you continue to use NUnit or MSTest, do not use expected exception, because it hides real errors. It's saying anywhere in this test case that something fails and throws this exception, you don't know where it happened. Was it the line that you were expecting that exception to actually be from? Who knows? It could be anywhere. So for that purpose, use either the exception recorder, or better yet, assert.throws of t, where you can specify what actual exception do you want it to throw. And you can have control over, do you want it to match that exact exception type, or are subclasses allowed? And depending on your scenario, it might matter. So please be explicit about that. And then beyond that, there's support for many, many different runners, from td.net or test-driven.net, and ReSharper have first-class support for xUnit, as well as then there's runners you can run as part of an MS build pipeline from the console, from Visual Studio in the Test Explorer window, and then now what we'll talk about is the device runner for your devices, but also of interest probably to many of you are support for DNX on Linux, as well as the core CLR support that is coming with RC2. So we have runners basically everywhere, just to reinforce the point that if there's a .NET platform out there, xUnit runs on it, and that way it's definitely one framework to learn, and it'll get you pretty much everywhere. So some examples here of, well, great, you have this extensibility, so what? Why do we care? And really as I mentioned, it's about letting you add custom behaviors without needing changes to the core engine. You don't need to go bug Brad or to accept your pull request to say, hey, look, there's this really cool thing I want. Why don't I have tests that have a culture in them? For many of you that are doing applications where you have localized versions of them, are you returning the right resources? Do you have different behavior based on whether the thread current culture is ENUS or ENUK? Maybe you spell color funny a little bit, right? Or maybe you need to support Portuguese or really any language-specific thing. So with an extensibility attribute, and a good example that I use in Humanizer is the use culture attribute. As you might imagine, for those of you that don't know, Humanizer is a library that makes it really easy to make human interactions with things like dates really easy. Take a date and say humanize, and it'll say 4 minutes ago or an hour ago. And you don't have to do all that fun math and figure all that out because we do it for you. It also supports 39 languages. So as you might imagine, we need to support unit tests for that to make sure that when you're in, say, I don't know, Czech, that you support the right language there. One of the things the Humanizer project does is have nearly 100% unit testing for all of this because it's an inherently easy problem to solve. You want to support a new language or add that support? Awesome, thank you. Thank you, community, because I don't know 39 languages. But at the same time, there's tests in there. So you submit the changes to the language resources that you might need, and at the same time, submit those language-specific tests. And now in this case, I can put a use culture attribute at the top of that test class, and all of my tests in there will execute as if they were in whatever the specified culture were. Another one, if you're doing anything with thread identity, you can put that in there, again, classic before, after test type of stuff. Before every test, set the thread current culture to whatever, and at the end, put it back to whatever it was. Another fun example that Andrew Arnott has written is skippable fact. Suppose you want to skip things at runtime. Maybe you don't want to use if-defs to cross-compile or conditionally compile things out, but you want to say, if you're on certain kinds of devices, run certain tests. Maybe you're on a device that has a GPS sensor, and maybe you're on one that doesn't. You want to run the GPS tests on those devices, and you don't really care about the ones that don't. On the other hand, you should have detection code, but that's, again, a different issue. So skippable fact has nothing to do with xUnit itself, other than implementing the necessary interfaces and extensibility points. What it does do, though, it's on NuGet. You can search for skippable fact, xUnit, is put skip.if, some condition. And at runtime, whatever you decide, it'll just show up as skipped. And you won't, have a sad face where all your test fails for an unknown reason. Database collections, again, pass a database instance into a test, easy to do. UI facts and theories. So many of you might be surprised to learn that xUnit core has no notion of a UI test, which would seem quite strange for some, devices where the UI is quite important. But the truth is, xUnit really doesn't care. It's executing tests on a thread pool for the most part. It's doing it really, really fast. Humanizer has something like 6,000 tests, and it runs it in under 2 seconds. So on the core CLR. So fantastic work there from the core CLR team who's implemented that runner. With the UI fact and UI theory, though, I was able to implement the device-specific mechanisms. On Android, it's the main looper. On iOS, you have the app delegate and the invoke methods. On Windows Phone and UWP, you have the dispatcher. So you have a common attribute. You don't really care about the implementation. You mark this as a UI fact or a UI theory, and your particular test method will run on the UI thread because we can change that behavior. So we can fully support tests that need to manipulate UI elements should you so desire. And there's tons more examples. Another good one that a guy named Garrett Serac wrote was an MS Test shim. So they had a big project. They had to support .NET. They were already using MS Test for desktop stuff. They were busy porting stuff to .NET Core, but guess what? .NET Core doesn't support MS Test yet. So they wanted to have their branch actually run on xUnit, but they didn't want to have a merge nightmare by changing all the attributes around. So he was able to implement MS Test attributes in the context of xUnit so that they actually run on xUnit, even though they look like MS Test attributes. Yes, it's compiled against xUnit or this library, but from a source code compatibility, it keeps things a lot more clean until they're ready to do a better cutover. And there's tons more examples on GitHub, so I encourage you to check them out. all kinds of extensibility examples. So then, xUnit for devices, and that's what we're really here to talk about. So hopefully I've shown you a little bit about xUnit and why it's been so popular and about its power there. The device runner was born out of the need to actually execute code outside of a common environment. Even if you write even if all of your business logic and the code you want to test is a portable class library, you still need to make sure that you test it on your devices. And I'll tell you why. Things like ahead of time compilation and .NET Native can wreak havoc on certain kinds of code. So even though it works just fine on the desktop, if you haven't tested it in release mode and native mode on your device, you can't be sure it's going to work. And certainly, then other kinds of things, like if you want to have anything that works with sensors or other device-specific capabilities, again, you're only going to be able to execute those tests on a device itself. So in the xUnit runner for devices it's a device runner. It uses the core libraries, and it's structured as an application in a box. It's a NuGet package. You can install it, and then, as we'll kind of walk through here, you replace your app delegate or main activity with some boilerplate code that it sticks in the project for you. I don't want to replace your existing app delegate or main activity in case you have done something outside of file new project. But nevertheless, hopefully you have just a dedicated, you just create a new blank app just to run these tests. And you host it, and then you can run it wherever you want, including on Test Cloud. So the Xamarin project here the support here was started in 2014, and that was shortly after or around the time of Xamarin Forms, so it was really fortuitous because I was able to take advantage of Xamarin Forms to write one UI that works everywhere. And I'll say this, I'm really good at writing ugly UIs, so I can write a really ugly UI that works everywhere, no problem, and for that purpose, quick and dirty Xamarin Forms was good for me. And I'm not trying to say that you can't make awesome UIs in Xamarin Forms. I mean, we've all seen them. But I'll leave that for more talented people on the UI side. So for me, it fit the need where I didn't want to have to write an iOS-specific runner and an Android-specific runner and a Windows Phone 8-specific runner. One set of code works everywhere. It was fantastic. So covered this a little bit. Again, a couple of other issues that crop up are the application sandbox and device permissions. Again, so if it's running in certain context, have you put the right permissions in your info.plist or your Android declarations or your Windows manifest, right? So if you need to test things, make sure it's right. Again, there's just no way around testing and running code on the device. You can run it in the simulator or a physical device. There's really no difference from this code's perspective. It's really, at the end of the day, just an application that you're hosting your tests. So with that, we're going to dive in and get started here. So we're going to sort of start with a blank application, add the NuGet package, replace the act delegates, and dive in. And then after that, hopefully you'll be able to do some of the same. So I'm going to switch over here to Visual Studio. All right. So I have taken one shortcut and just to save a little bit of time, and that's that instead of going File, New Project, and adding a bunch of stuff, I kind of cheated, and I did that, and I added the NuGet references, but I haven't added any code yet. So all I've done is I've created an iOS project, an Android project. I have a portable class library that has some awesome business logic in there. It has a view model I want to test, and it has a blank test class in here. So as you can see, there's really nothing here, and with that, we can dive in. So after adding the NuGet package to your iOS or Android project, you'll see a main activity.cs.text or a corresponding app delegate. On Windows Phone 8, you'll see an app.xaml.cs .text and then an app.xaml.text because it needs to override both of those for the application class. The idea here is, again, for the most part, just copy and paste. Select all. I've already put the namespaces you should expect and replace it. There really should be nothing to think about here for the most part. Oh, thanks, ReSharper. And we'll just do the same again for iOS. Let's put And we can pretty much forget about this. The one thing that might want to pay attention, by default, at least as in the template, it will detect any tests that are in the application project itself. And that means we can just, if you're using a shared code project, which is often handy for these, because I can just have a shared code and it'll compile into each one and can if-def things out as needed. It works really well for unit tests because now I don't have to worry about the limitations of a PCL 259 and kind of all kinds of ugly hacks just to write unit tests. So shared code projects work really well for this, and as a result, this works just fine out of the box because your unit tests will actually be compiled into the application itself. However, if you want to have your unit tests in a PCL, and maybe that your view model isn't just a regular library, that's awesome. And you can just comment this line and change it to find a type and add the assembly. And we need to do that to get around the iOS and Android linkers to make sure that it pulls in your portable class library and doesn't do funny things with it. So one extra line of code here if your unit tests are in another library, but otherwise it's not really any different. So let's come in and start writing a unit test here. So as I mentioned, I have a blank test class, and I'm going to come in here and add a fact. So let's come in here. Yep. All right, so this is not to bore you with my incredibly awesome on-stage typing, but we're following the AAA pattern here of arranged, act, and assert. So we're going to start by declaring what it is we want to do in our unit test. In this case, we're just creating a view model instance. We're going to act. We're going to do something on it. In this case, we're going to add, we have this method here called add, and hopefully it does as the name implies, which is to say, gives us 5. So we can go ahead and run this here, and we will see that hopefully it does. So let me pull this up, and we'll see it should be running here on, as it loads here. I'm going to use the Visual Studio emulator for Android because it's pretty darn fast. So once it just compiles here, and I've already added my main activity, it's going to come in and fire up this application with this test. Oh, and that was not expected. Let's go back here and do it one more time. Main activity. Oh, must have forgotten to save it here. All right. So if you forget to copy the main activity, there you go. It'll be pretty obvious. Your unit test won't be there, and it won't look like that. So in just a second here, it'll build and deploy this, and we will have our test runner. Okay. Looking good. And that's what we were looking for here. All right. So really, it's, again, I told you up front, it's a really ugly-looking app. If you want to make it better, please accept pull requests. So by all means. In fact, one of the features we have in here, which is the ability to filter and search by status, was added. Oh, fantastic. Well, there's a bug somewhere in the emulator. So there's a drop-down filter in here that lets you filter by test status, and that's if you have if you have like 100 tests in there, you want to say, hey, which one's passed or which one failed, you can drop down and filter by that. That was a community contribution, so thank you to the community member who did that. If there's other features you want to see, you can go ahead and do that. So we can go ahead and either run everything or run each individual test, and very quickly we say, yay, this passed. One success, and there's really nothing to see here other than, yes, it's successful. So let's come back in here, and as we mentioned, facts are great. They test one thing, but so far, in the grand scheme of numbers, I've tested one combination, 2 and 3. Yay, okay, I get 5. So let's go ahead and add a theory with a few rows. In this case, xUnit calls them inline data. As mentioned, you can use the other points where you can specify methods with enumerables or get your data wherever you want. So I'm going to test a few other cases with some numbers and positive values, and let's see what happens in this case. All right, so the first thing we'll notice is actually that we have 4 test cases. And that's because xUnit enumerated them and said, you know what? It's really not 2, because we have the one we talked about earlier. That was the first one we did. But we actually have 4. We have here's the first one we did, test added. But now it lists each theory independently. That is configurable. You can disable enumeration in the case where there might be thousands of individual things, and that might be a challenge to sort through. So that is configurable as well. But I can go here and run them all, or in this case, filtered and all are the same. And I can see that I have a failure, and that something happened. 2 and 3, -5 plus -3 did not give us the expected answer. And we can check out our stack trace and go on from there. Go ahead and fix it. And if we come into the view model, we'll see that, oh, someone decided that, for demoware, we'll put in absolute value and make negative numbers not really work right. So wanted to add one other thing in here, and that's this skippable fact. So suppose we want to have a test, as we said, that only runs on certain days of the week. Because you're taking, say, Monday off, and you don't want to have anyone yell at you that day. So there we go. This will only run if the day of the week is not Monday. No one's going to know, right? So as you can see, it's pretty straightforward. I have skippable fact. I don't need a fact anymore because it is a fact, and it implements the same extensibility points in there. And then when it comes up in here, when I run everything, I can see that one of them is skipped. And here, hey, guess what? This test only runs on Mondays. So you put, of course, whatever message makes sense to you. But that's the crux of it here. And just to show you that it all works the same on iOS, let me just stop this here and switch over to the Mac. Go. And we pull this up here, same code. I haven't done anything other than hit compile or build. In a second. Come on, Xamarin. Here we go. There we go, iOS App Runner. And we can say here, the same things. We have all of our tests. It's, really awesome in, design. Again, pull requests welcome. Please make it pretty. And I can run everything. It is getting cut off on the bottom here from the resolution, but it is what it is. But again, it's really the same thing, and hopefully you can see that it's all here. And we can get to see the success and failures. So say this is a failure, and the stack trace looks slightly different because we have the iOS gobbledygook in here before we get to our shared test class. Switch back here to the PC. So running tests across platform, as I mentioned, you kind of have two main options. You have the ability to do things with portable class libraries or in shared code. And I love PCLs. I'm a huge fan. At the same time, they can be, let's face it, quite restricting. You can, there's just not a lot you can do if you need to do things, say, with cryptography. There's things you can't do if you need to do things with certain networking classes. And certainly things if you want to do or work with the native UI widgets. So depending on your scenario, shared code might be more appropriate. And as mentioned, in the case of unit tests, I think shared code is a really good way to go, because it's really easy just to have a file there. And in a unit test, you're more likely going to want to touch some of the platform-specific components, and you're not really worried about shipping it out as part of a library in that case. But that said, if everything fits in a PCL, knock yourselves out. You can add the xUnit reference to the PCL, and you're good to go. So it becomes a question over design. And I guess with that, I just want to say that xUnit works everywhere. It's extensible, and it's really fast. So let's see if there's any. Take it for questions. I have some time here, and take it from there. Here, I think there's some mics coming around.
Is it working? Yeah. Thanks, Oren, for the presentation. Just a quick question. When is it planned to compatibility with the test cloud?
So yeah, it's a great question. Thank you for asking it. I knew someone was going to. So right now, the best way of executing xUnit with Test Cloud is as an app. As mentioned, this is it's an application that runs on your device, and you could put a coded UI test, as was demonstrated on stage yesterday, to just click that Run Everything button. And you can put an assert on there to check to make sure that you have 0 failures in that string. Certainly, tighter integration is something that we'd like to do, but we're an open source project. We're happy to do it. As far as I know right now, the Test Cloud backend APIs are not open, so really Xamarin needs to hear it from you. If you want first-class xUnit support in Test Cloud, let them know, because then they'll, like anybody else, they're listening to their customer feedback and priorities.
Yeah, and another quick question. So all tests you were running in kind of iOS runner or Android runner, like on device or an emulator, can you run it just in Visual Studio, like a normal unit tests?
Sure. So that's the challenge. Visual Studio itself doesn't really have the ability to run tests on remote devices. It doesn't even really do it. Even the way they do it for UWP and Windows Store projects is a really big hack. It's not at all documented. So, and how they wire up that machinery to fire up those mechanisms. So certainly, what we would need for that is a way to spin up an emulator or VM, deploy, execute, and get results back. We have what we need on our side in the terms of what I didn't show you here is in that main delegate, you can put a text writer, you can do anything, you can put a socket on there. We can get data out of the test to a network machine or to a remote location, but you need support within the Visual Studio test framework itself for actually getting that test deployed for discovery and execution. Because you're just not going to be able to execute an iOS test on the desktop framework. So it has to run on the device, and it's really that communication between the two. Thanks.
You run the tests in a random order. Mm-hmm. Is there any way, if you get a failure, to rerun exactly the same order to debug that?
So as far as I know, no. And really the question is, and I'd be curious to see a scenario around this, of where you have a failure that is order specific, because hopefully that's pointing to some dependency within there, and might go in, if you do see a failure, let's examine that test itself to say, are we doing things around static variables and static state? And that's probably the most common place where you might see things. And I would always be very wary of statics in general, especially in tests. And again, that might just be a good pointer to take a closer look in there. But at least you have a starting point that say something in here might be order affected.
There's a lot of time in our testing where I know this kind of goes beyond unit testing, but we have to hit an endpoint or we have to hit a database. Is there any sort of tools or packages or anything out there that helps stub those things out, that kind of automatically stubs any of that stuff out?
Sure, great question. So in this case, are you looking at mocking out interfaces for things, or are you looking at, at what layer are you looking to stub things out?
Well, there's some of it's all the way end to end. We have test within test, and then tests that build upon different layers. And we have a big test harness. Our API is not very well documented, so we have a big test harness that anytime we add something to our API, we need to understand what our API is doing. We have to do that, but we have to go against that API to actually kind of see how it's performing, because it's such an old API.
Right.
So, but there's some
So there's many approaches to that. Due to some of the limitations within particularly iOS around code generation, some tools like mock don't really work well because they can't emit code at runtime. So you would typically can do things around interfaces where you can stub them out, create other implementations, and certain patterns like dependency injection may help in those scenarios where you can have your data access layer, whatever it might be, implement a specific interface. And you can substitute that out. Again, at the end of the day, your unit test is just an application. So if you have a container you're using, you can do that. And say, look, your test could be sometimes running against a mock or sometimes running against the real implementation in the context of more of an integration test. And you could do that at runtime, or based on whatever condition you want, like however you want to configure your container.
Just a general question. So what is the best way, or is there a better way to unit test production code that references NuGet packages other than creating facades for them and injecting that dependency?
So I guess some clarification. So you create unit tests for code that references NuGet packages. Can you give me maybe a concrete example?
So for example, if I have some code that uses PCL storage, and it calls in there if file exists, and it'll do something if it does, or something else if it doesn't. And I need to stub that, basically that NuGet, my PCL storage. Is there any way to do it better than just creating a facade for it and injecting it?
I think it's going to be a very similar answer to the previous gentleman in that certain operating systems don't really allow full in-depth. Basically, there's no equivalent of type mock in iOS or Windows Store. You don't have access to those profiler APIs. There are some tools like type mock isolator, which can go really deep. They hook into the profiler APIs. They can replace statics. They can fake out datetime.now. And that's really cool when you want to control that. But that is very dependent on support from the underlying platform, and not as much as the unit test framework itself. So you're going to have to probably fall back to more common testability patterns where you identify points where you might need to stub certain things out. And code generation can help. So one great example, and shameless plug out to Paul Betts's refit library, is it's a REST library where all you have to do is create an interface to your service, my service. You put a method on there, you put an attribute on there that says, hey, here's what the endpoint is, and it uses, by convention, it'll automatically take any parameters and stick them on the query string, or any strongly typed objects, and if it's a post, for example, it'll turn that into, JSON serialized into a post, and you put the same thing on a task of t return parameter. For declaring my REST interfaces, that's all I have to do, because at compile time, there's a task that goes in there and looks for those interfaces, and it's decorated by the refit attribute. And it generates code to implement that interface to actually do all the boring plumbing work of hooking up HTTP client and doing the calls, checking status results, and the like. So a similar approach may work where you can have basically compile time tasks to generate code and implementations of your interfaces. Okay, well, with that, I guess I think lunch is coming up next, and I thank you for your time. Hopefully, enjoy the rest of Evolve.